Hello, k times k times k minus k times k equal to 100. How do we solve for k? Without further delay, let's begin. Solution. We have k times k times k minus k times k equal to 100. This guy is the same thing as k to the power of 3 minus k times k is simply k to the power of 2 equal to 100. The next step now is to transfer this guy to the left side. Doing that, we have k to the power of 3 minus k to the power of 2 minus 100 equal to 0. K to the power of 3 minus k to the power of 2 minus, we can rewrite 100 as 125 minus 25 equal to 0 for simplicity. Let's proceed further. K to the power of 3 minus k to the power of 2 minus times 125, that is negative 125, minus times minus 25, that is plus 25, equal to 0. Now, we have to break down this guy and this. So let's proceed further. We have k to the power of 3 minus k to the power of 2 minus 125 is the same thing as writing 5 to the power of 3 plus, we can rewrite 25 as 5 to the power of 2 equals to 0. Now, let's combine this guy and this. They look similar. So we have k to the power of 3 minus 5 to the power of 3. Likewise, this guy and this. Minus k to the power of 2 plus 5 to the power of 2 equal to 0. So, k to the power of 3 minus 5 to the power of 3. We can pull out negative sign out here. So, we're going to have minus into k to the power of 2 minus 5 to the power of 2 equal to 0. Because minus times k square, that is negative k square, minus times minus 5 square, that is plus 5 square. Let's proceed further. Now, let us recall the difference of 2 cube. It says a to the power of 3 minus b to the power of 3 is equal to a minus b times a square plus ab plus b square. Let's take note of this property. It is possible to apply this property to this guy, k to the power of 3 minus 5 to the power of 3. Let's just simply isolate it. By comparing this guy with this, you will observe that our a is k and our b is 5. Let us substitute a and b into this right hand side. So we're going to have k minus 5 times a. What is a? A is k. So we have k to the power of 2 plus ab, that is k times 5, 5k plus b square. What is b? B is 5. So 5 to the power of 2, that is 25, minus this guy, k to the power of 2 minus 5 to the power of 2 equal to 0. Let's proceed further. K minus 5 times k to the power of 2 plus 5k plus 25 minus, this guy is a difference of 2 square. We can rewrite it as k minus 5 times k plus 5 equal to 0. Now, you will observe something. We have k minus 5 here. Also, we have k minus 5 here. We can factor it out. Doing that, we're going to have k minus 5 into this guy, k squared plus 5k plus 25 minus this guy, k plus 5 equals to 0. So we have k minus 5 times k squared plus 5k plus 25 minus times k, that is negative k, minus times 5, that is minus 5, equal to 0. This implies that k minus 5 times k squared plus 5k minus k, that is 4k, 25 minus 5, that is plus 20, equal to 0. This implies that k minus 5 is equal to 0, or k to the power of 2 plus 4k plus 20 is equal to 0. Clearly, from this guy, k is equals to 5. This is our first solution. Now, let's consider this guy. We can solve this quadratic equation using quadratic formula. You should recall this formula. K equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Clearly, a is equals to 1, the coefficient of k squared, B is equals to 4, the coefficient of k, and C is equals to 20. Substituting these values into this guy, we have k equal to minus, what is B? B is 4, plus or minus square root of B is 4, that will be 4 to the power of 2 minus 4 times A is 1 and C is 20 times 1 times 20 all over 2 times 1. So k is equals to minus 4 plus or minus square root of 4 to the power of 2, that is simply 16, minus 4 times 1 times 20, that is 80, over 2 times 1, that is 2. K is equals to negative 4 plus or minus square root of 16 minus 80, that is what? That is negative 64 over 2. So we have k equal to minus 4 plus or minus. We can rewrite square root of negative 64 as square root of 64 times square root of negative 1 over 2. So k is equals to negative 4 plus or minus. Square root of 64 is what? Square root of 64 is 8. And square root of negative 1 from the complex number is I over 2. We can pull out positive 2 out. So doing that, we have k equal to 2 into negative 2 plus or minus 4i over 2. Clearly, this guy cancel each other. So we are left with k is equal to negative 2 plus or minus 4i. This is the second solution. Therefore, k1 is equals to 5. This is the first solution. From here, k2 is equal to negative 2 plus 4i. And the third solution, which is k3, is equals to negative 2 minus 4i. These are all the required value of k for this beautiful equation. That's it for this video. Thanks for watching.